Hello, everyone, and welcome to Chapter 6, Linear Functions. Okay, throughout this chapter, we're going to learn a lot about how to graph lines, how to use and create equations to solve word problems, how to find the solution of systems of equations. We're going to do it both graphically and algebraically. We're going to really learn how to manipulate equations so that they're helpful to us. So to start this chapter off, the first lesson, we're going to talk about slope, graphing points in the Cartesian plane, which is the xy coordinate plane, and we're going to also understand function notation. Now, there's going to be plenty of times in this unit I'm going to ask you to stop the video, to try an example, and then we could always check our work. So as a warm-up, what do you remember about linear functions? Make a list of any topics that you remember, that you've learned in previous courses, that you've seen before. Go ahead, pause the video, and when you're ready, unpause, and I will move on. Okay, let's take a look at some of the things that I generally hear from students. Okay, a lot of students like to say, oh, that's the y equals mxb. Yeah, y equals mx plus b is called slope-intercept form. We're going to learn about that form. There's other equation forms that we're going to learn about as well. Okay, linear functions are straight lines. Okay, if it's curved, it's a different type of function. It's got constant growth, and that refers to the slope, and we're going to calculate the slope given points, given equations, and given graphs. So throughout this chapter, we're going to learn how to deal with graphs and equations and tables and situations and word problems. Now, some of the terms you see here, you're more than welcome to pause the video right now if you would like to copy them down. But these are just some of the terms we're going to be talking about today. We have slope, we have what a function is, function notation, and the Cartesian plane. So let's start off with something that we're all pretty comfortable with, the xy coordinate plane. This is called the Cartesian plane. We have the x-axis and the y-axis. Now, it's really important to know that this top right is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So we start in the top right, we go counterclockwise and label the quadrants. So if a problem ever tells you we're dealing with a quadrant 1 point, we only need to graph the top right, so we can make a 1-quadrant graph. We don't need the rest. For everything else, though, we'll need a 4-quadrant graph. And here we got a point in quadrant 2. So we can name the quadrants. We can also name this point. So go ahead, write down the coordinates for this point. Now, hopefully you did, and you said, okay, that point's negative 4, 1. I know how to name a point. I go over x first and then go up y. X is the first one, y is the second one. But if you forgot, here's a nice review. Now, slope is also a very important indicator for a function. Okay, it's really important to know how fast I'm going up. So slope, steepness, growth, those are all terms to describe how quick this line's going up. Now, if it's going up and to the right, it's positive slope. And if it's going down and to the right, it's got a negative slope. I like to think I walk from left to right if I go uphill or do I go downhill. So now we got to find the slope of this graph. So you may be familiar with slope is rise over run, the change in y over the change in x. There's other formulas for it, but I'm going to stick with rise over run. So the first thing we got to do is we got to pick 2 points on the graph. Now I could pick a random point, but I don't want to deal with fractions or decimals. So what I'm going to do is I'm going to pick something called lattice points. I'm going to pick points that are at integer values that are nice points where the horizontal and the vertical lines meet. So I have -6, -8, and 0, 4. And if I could pick a point on an axis, it's really nice, but not really necessary. Now it says slope is rise over run. So I'm going to figure out, I go up 12 and over 6. And I'm going to make sure that my scale is going up by 2. So I count 2, 4, 6, 8, 10, 12. Because sometimes my scales are different. Sometimes each line is going up 1, or maybe in this case it's going up 2. So my rise is 12, my run is 6, and I know it's positive slope. Now, I could write 12 divided by 6, but I probably want to simplify it to 2. Okay, I like to simplify my fractions if possible. If it becomes an integer, I like that, so that I can easily put that in an equation. Now, let's say I didn't give you a graph. Let's say I just gave you 2 points. We can find the slope between them as well. Now, if you want to, you're always welcome. Take out your graph paper, you can put the points on a graph and use the same method we just learned. Or we're going to see that we can do the same idea, we just don't have a graph. So slope is, this is another way to write it. It's the change in y over the change in x. Okay, there should be a parenthesis there. No harm, no foul. Now we got to figure out how much we change the height and how much we change the x. So I like to show it like this, where to go from -8 to 4, I go up 12, and then go from -6 to 0, I go over 6. And I like to put my y's on the top and the x is on the bottom because it's change in y divided by change in x. Some people like to put it in this formula. They take this as y2, so the 4 minus the -8, and you got 0 minus -6, and make sure our calculations are accurate. We got 2 negatives, which means an addition. So 4 minus -8, 0 minus -6. We still have 12 divided by 6 equals 2, because these were the 2 points on our last example on the graph. So the slope should still stay the same. Now, what I do like to do is I like to make a little sketch and say, well, -6, 8 is here and 0, 4 is here. So I know that it should be a positive slope, because that's something that people tend to make mistakes on. They don't think, well, should the slope be positive or negative? But if they have a picture, they know, oh, this is going up and to the right, so it should be positive. It should be a positive slope. So now we know how to find the slope between 2 points on a graph and 2 points just if I give them to you. Now, functions. A function is a very complex name. It's a mathematical machine. It's a mathematical equation. We generally use x for the input and then f of x for the output. We could use y for the output, but we use f, which means function in terms of x. So we put out in x, we get out f of x. Now, for something to be a function, if I put in an x, only one thing can come out. So let's look at this example. F of x equals 2x plus 9. So I'm taking whatever I put in, I'm multiplying by 2, which in this case is my slope, and then I'm adding 9 to it. So if I say f of 5, it means that when I put in 5 for x, what do I get out? So put in 5 for x, I'm going to multiply it by 2, so 2 times 5 is 10, plus 9 is 19. So f of 5, an input of 5, gets us an output of 19. Now, this is a linear function. We're also going to see that this semester we got quadratic functions and exponential functions, a whole bunch of other functions. And some that don't have a great name, that they just do an operation. This is saying double your number and add 9. That's what this machine does. So here are some for you to try. Now, I recommend you pause the video. You try all 4 of these, and you tell yourself, well, I can do all 4 of them, or I'm not sure how to do one of them. Then you unpause the video. I will walk you through all 4 of them. So go ahead, pause the video, and when you're ready, check the answers. Okay, let's take a look at the 4 of these. So the first one, I got f of 5. So my input is 5. So I put 5 in, 5 squared minus 2 is 23. Okay, this isn't linear, but I could still use this function. It tells me to square my number, subtract 2. So same thing with 0. 0 squared is 0, minus 2 is negative 2. Now this one, they don't give us the input, they give us the output. So we're going to substitute 7 in for f of x. So we're going to put 7 on the side where y normally is, and then we're going to solve this. Now we're going to use the operations to solve like we have in the past. We can add 2, and then we could take the square root. Now in this case, it's interesting because x could be a 3, because 3 squared is 9, and x could also be negative 3. So sometimes two different inputs give us the same output. If I put 3 in here, I'd get a 7, and if I put negative 3, I'd get a 7. That's okay. Each input can do one thing. Multiple different inputs could give us the same output. That's okay. And then this last case says put n in for the input. So all it's telling us to do is instead of x, we put n in. It says x becomes n. Now I can't do anything with it. N's not a number, so I can't get out a final answer. It's just a single number. So I leave it like that. So in this lesson, we learned about function notation, graphing, slopes, and the coordinate plane. Now there are some examples for you to try. There's some assigned Khan Academies. Make sure you practice these so you're prepared for the next lesson.